Today we're going to finish up on engine assembly, uh, how to get the piston assembly, connecting rod, camshaft, and the crankcase cover installed properly. So we kind of finished off yesterday with kind of right around installing the piston to the connecting rod, but we're going to continue on with that lesson from yesterday. Match marks are used on many of the connecting rods to get the piston and rod assembly orientated correctly. They're also used to get the parts orientated in the engine right. Some pistons have arrows or notches in them that must face a certain direction, and you'll always want to check the service manual to make sure that those marks are aligned properly. If we look over here at this picture here, this is a Honda piston and rod out of a GX 160. You'll notice a mark right here has to line up with this oil hole right here. So many engines have these marks that make sure that you get that piston orientated to the connecting rod properly. You just can't throw a piston on a rod and hope that's good. Never place the piston on a solid hard surface when you're installing the pin. Sometimes these pins will slide right in nicely. Most of the time, a brand new piston, brand new connecting rod, new pin, the piston pin will slide in, but sometimes you have to tap them a little bit. Just don't put the piston on a hard surface while you're doing it. Wooden surface is fine. Piece of cardboard is even better. Just if you have to tap that piston in there, don't put it on a hard surface so you don't destroy it. Some two-stroke pins are hollow on one side and closed on the other. The closed end must face toward the exhaust side if you have that. That's only going to be on two-stroke small engines, not two-stroke motorcycles. Always use new circlips when you're installing the piston pin. Old circlips can fall out and allow the piston pin to come out and rub against the cylinder wall, which will destroy your piston, your cylinder walls, and basically your whole engine. So you got like a 15-cent part that can do a lot of money worth of damage. So make sure you just put those new circlips in there each time. First question of today is the connecting rod can be installed in the piston in any direction. Is this A, true, or B, false? Yeah, I say, wow, that's a lot to remember. So what's the bottom line here? Between yesterday's lesson and today, there's a lot to remember. What's the bottom line? You're going to need a service manual to get it right. Don't just rely on, I think that's how it works. Get a service manual, use a service manual in order to get these things right. Installing four-stroke piston rings. Piston rings are always replaced when you're overhauling an engine. You don't want to put an old set of rings into a brand new engine. You want to have all the brand new parts in there. When installing them on the piston, follow the directions supplied with the rings or the service manual. Most of the time, you'll get a little slip of paper. I know like Briggs and Stratton, you'll get a little slip of paper inside the ring box that shows how to install those and the proper orientation of those. There's three things that you must remember when you're installing rings. They must have the correct ring end gap. They must be orientated in the correct direction, and they must be in the correct piston groove. So let's take a look at the next question here. Piston rings must be installed, A, before the rod is assembled to the piston, B, with the indicator marks down, C, according to manufacturer's instructions, or D, with the tapered side down. The ring end gap is the distance between the ends of the rings when they're squarely positioned inside the cylinder. And then in order to check the ring end gap, this is really important. That has to be done before you assemble the piston rings onto the piston. You always want to do this on any time you're installing the rings. The way we do it is we put one ring into the cylinder. We push it down with a piston, about an inch or so down inside the cylinder. And then you're going to use a feeler gauge to measure the ring end gap. What I do is I start out with a smaller feeler gauge and I just keep working my way up. I put a little bit bigger one on there, a little bit bigger, until you get slight drag on those, on your feeler gauge. That's when you know that's what the ring on gap is. Many people will stop. They'll say, well, it's a 5/1000 of an inch ring on gap, but they didn't check 6, they didn't check 7, they didn't check 8, and it really came out to be an 8/1000 because they stopped too soon. Do that for all your rings. So you're going to have typical 4-strokes is going to have your top ring, top 2 rings. You're going to be doing it for that, and your oil ring also. Too little ring end gap causes the rings to butt against each other when it warms up. When they start to expand, the ring end gap will get smaller and smaller and smaller. So we're looking right here. It's getting smaller and smaller and smaller right there. And if that gap goes away and they touch each other, you're going to have a ring failure and you're going to destroy your engine. Now on the other side, too much ring end gap causes compression loss or oil loss. You're going to use too much oil. So you want to make sure that those are within specifications. Next question of the day. The ring end gap is the distance between the A, side ring and piston grooves, B, ring and cylinder wall when installed in a cylinder, C, the compression ring and oil ring, or D, ends of the ring when squarely positioned in the cylinder. Piston rings must be installed according to the service manual for that engine. And as I said a little bit earlier, there's instructions either with the piston or in the service manual. You got to make sure you follow those instructions. If the piston rings are installed upside down, they will not work and can cause engine damage. And some rings have dots or marks on them that must face up. So if you see any markings on the top or the rings, top of the rings, make sure they're facing straight up. Another question, if the rings have markings on them, which way do they face? Up or down? To prevent ring breakage, use a piston ring expander to install the rings. Install the bottom ring first, then work your way up to the top ring. On the 4-stroke engines, you have to space those ring end gaps about 120 degrees apart so that the oil and the compression does not leak past them. If we look at this picture over right here, you'll see this tool right here. That's the ring expander. Basically, it fits into the ring end gap and it expands it out. So you're only going to expand the ring just enough to slide it over. You can break rings using these tools. So just enough to slide that ring over the piston, and that's all you need to do. Don't over expand those rings with those tools. Now some oil control rings are made in 3 pieces. This is pretty common today. They're using a 3-piece oil ring. It's been used for years and years in the automotive side, the motorcycle and ATV side, and you're finding most engines today use a 3-piece oil ring. These types of rings have 2 side rails and 1 center spacer. So if we look at this picture right here, you can see this is the center spacer. And here's the side rail, the bottom side rail here, top side rail here. The center spacer is always installed first, making sure the ends are not overlapped. We're looking at this picture down here on the bottom left, and you see the butt right there. You got to make sure that they butt up against each other. If these are overlapped, the ring will fail and it won't work right. You'll be burning oil like crazy. After you get these things butt, what I do is I actually color these with a marker or something like that. You know, something bright colored right here. And that way there I can see that gap a lot better also. Install your bottom ring rail first and offset the end gap about 1 inch to the left of this right here. So then you're going to follow it up by your top rail. And this time you're going to put the end over on this side about 1 inch. So when you get these all installed, you're going to have your center rail here. Then you're going to have the end gap of the bottom rail over here about 1 inch. And the top rail end gap is going to be somewhere over here on the right, about 1 inch. So that staggers all the ring gap openings on the oil rings. Now, 2-stroke piston rings are different than 4-stroke rings. You don't have your oil control ring. You only have compression rings. You could have 2 compression rings or maybe even 1 compression ring. You check the service manual to see if the rings are the same. Sometimes they have to go in specific grooves. Some rings may be the same and can be installed either side up, while others must be installed a certain side up. Rings that must be installed a certain side up will usually have some type of marking, such as a T or a dot or letters. Looking at this picture over here on the left, that T right there, that tells us that that has to face up on the piston. And most 2-stroke pistons have knock pins that stop the rings from rotating around the piston. The knock pin right here in this picture is put in there to stop these rings from rotating. In a 2-stroke, you have big open ports. Your exhaust port's a big opening. Your intake port could be a big opening. And if the rings were able to rotate, once those end gaps came into one of those big open ports, they would come open and then catch on the cylinder and destroy the cylinder and the piston. So they have to have these knock pins in here. The ring end gap must align with the knock pins, just like in this picture, right there. So now we've got the piston installed at a connecting rod. We've installed the pistons onto the rod, or the piston rings onto the piston. And now we want to do one more check before we start to really assemble the engine. And this is the clearance between the connecting rod bearing and the crankshaft journal. This is an oil clearance. We got to have an oil clearance, a small oil clearance for oil to go through. And we always check this anytime you suspect an internal engine noise problem. Maybe the customer complained of an engine knock before you tore this down. Anytime you install new lower end parts, so if you put a new connecting rod in, you got to check this clearance. If you put a new crankshaft in, you got to check this clearance. If you had any machine work done to the rod, journals, you got to check this clearance. And we also do it anytime we reassemble an engine. So what we use for this is a thickness gauge. Most of us call it plastic gauge. Plastic gauge is the common name. It's actually a brand name, but it's what everybody calls the stuff is plastic gauge. So we use this plastic gauge to measure the oil clearance between the connecting rod and the crankpin journal. Now, too little clearance between these parts can cause rapid wear due to overheating. Can't get enough oil in there, and then they start causing friction, and they overheat and seize. Too much clearance causes rapid wear and early parts failure. It also causes a lot of knocking noise too if you get too much noise in there. If the clearance is not within the specification, don't assemble the engine. Find out what's wrong. So make sure that you fix the problem before you continue if this doesn't come within the specifications. Next question of the day. Connecting rod to crankshaft clearance should be measured A, if diagnosing an internal engine problem, B, when installing new lower end parts, C, during any reassembly, or D, all the above. Another question. Connecting rod to crankshaft clearance can best be measured using A, a dial indicator, B, a telescoping gauge and micrometer, C, vernier caliper, or D, thickness gauge. So how do we do the plastic gauge? It's a pretty simple process. To use plastic gauge, first we cut a piece of the plastic gauge about an eighth inch shorter than the connecting rod bearing. So you cut a piece of plastic gauge off, you lay it sideways on the crankshaft journal. You first you should wipe the journal good and clean. Wipe the rod, make sure that's nice and clean. Oil doesn't make it stick very well, so we got to make sure they're clean. Place the plastic gauge on the rod bearing, then assemble the cap to the journal in the correct direction. Make sure that the cap is installed in the correct direction to the connecting rod, and torque the rod cap down the specified torque. Don't rotate the crankshaft or the plastic gauge will be ruined. So what I do is I position that in such a way that the crankshaft can't turn, the connecting rod can't spin around. Then you loosen up the rod cap, take the rod cap off, and look at the flattened plastic gauge. On the paper, on the wrapper, is the gauge that you use to determine what the clearance is. And you simply just line up, here's my flattened plastic gauge, and this is the one that is the same thickness. And if I look down here, this looks like this is 2/1000ths of an inch clearance. A wide strip indicates a smaller clearance, like right here. If you look at this wide strip right here, that indicates a 1/1000th of an inch. And a thin strip right here indicates 3/1000ths of an inch clearance. So this stuff works amazingly well. It's really not very expensive. It's pretty cheap stuff. And it works really, really well on this. It's actually designed, I read, during World War II for aircraft engines. That's where they first came up with this stuff. So now that we have the clearance right, we know that that's within specifications. Now we're getting ready to install the crankshaft and piston assembly. So with the oil clearances within specs, clean off all the plastic gauge. I use my thumbnail, works pretty good. Just use thumbnail, scratches it off. Take a clean rag, and clean the journals and everything off. Oil up all your main bearings and crankshaft journals with assembly lube. Remember, that was like that grease that we talked about yesterday. Make sure everything is very clean. Then wipe the cylinder walls with engine oil. Lube up the piston and the rings assembly. You can either dunk it in some clean oil, or just use a rag with clean oil, or your clean fingers. Dip your fingers in the oil and lubricate the piston and rings really good. And then slide the crankshaft into the engine block. Now it's time to put the piston in place. And before we do that, we need to install this tool right here. This is called a ring compressor. And what the ring compressor does is compresses the rings so that the piston and rings can slide down in the cylinder. Make sure the piston faces the correct direction according to the service manual, and that the piston and ring assembly are oiled up good. And then you're going to tap the piston down in a position so the connecting rod is around the crank pin journal. What I do is I'll actually use the end of a small wooden handle on, like, say, a ball peen hammer. And then what I'll do is I'll tap it down lightly. There's the key word, lightly. And I'll keep tapping until it goes down inside and the ring compressor pops loose. Now, if it stops, the piston stops on the way down, the ring is likely has popped out right down here at the top of the cylinder. So if that happens, and if you keep bashing on it, you're going to destroy the ring. So that's why I say tap lightly, and it'll just keep moving ever so slightly. But if it stops, you got to start all over. Next question. The piston and ring assembly should be installed into the cylinder. A, dry to ensure rapid break-in. B, after coating with oil. C, after coating with bearing grease. Or D, after spraying with penetrating oil. Now we've got the piston and the connecting rod. You can see the connecting rod in this picture right here. It's around the crankshaft journal. And so now we have to put this cap on in the proper direction. So line up the rod cap properly according to whatever the service manual says, and it's got to be installed in the proper direction. If the oil dipper is used and not installed in the correct direction, it'll not throw the oil around, and the parts won't get lubricated properly, and this is going to cause engine damage. Torque the rod cap bolts to the specified torque. And some of the older engines, your older Briggs & Stratton, they use these lock plates. These lock plates went on first, then the bolts, then you torque the bolts down. Once you got the bolts torqued, then you would use like a pair of pliers and you would bend the lock plate around the bolt to lock that bolt. There's no way the bolt can ever loosen up when that's done. I really haven't seen those in a long time. Those are like 80s engine on back. You probably won't ever run into that, but sometimes you do. Another question for you. The connecting rod cap, A, must be installed in the proper direction. B, requires a 10% torque increase on used rods. C, can be installed in any direction if new. Or D, must have alignment marks toward the flywheel. So now we have the connecting rod fastened to the crankshaft. It's time to put the cam and the lifters in. First thing we're going to do is oil and insert the valve lifters in their correct position. You can't really see it in this picture, but it's kind of behind there. There's two lifters that we slide in there. Rotate the crankshaft so the piston is at top dead center. Oil the lobes on the camshaft and all the journals, and insert the camshaft, making sure that these timing marks over here are lined up. You'll see this mark on the cam. You'll see this little mark on the timing gear. Make sure that these are lined up. Sometimes actually we'll just like bevel the tooth on a gear on the cam and bevel a tooth on the gear on the crank. You got to make sure those alignment marks are lined up. Otherwise, the camshaft's going to be all out of time. It's not going to run. And then on Briggs & Stratton, they have an oil slinger that slips right over the end of this cam right here, the oil slinger. So make sure you put that oil slinger on there. This is a Honda motor. They don't use oil slingers on those. Now the next big thing is to check the clearance between the end of the gear on the crankshaft and the bottom of the bearing that sits under here in the crankcase cover. So the way we do it is we install the crankcase cover, then check the end play by, this is a tool that I just made. This is my dial indicator. And what I do is I'll either push this up or I'll push this down, doesn't matter. Whatever you do, push it, let's say push it down. And I'm going to zero. I'm going to rotate this bezel ring around here until the zero lines up with the pointer. And then I'm going to pull this up and I'm going to read how many thousandths of an inch clearance there is between those, the bearing and the gear under here. You can't really see this, but like the clearance, you can't see it. It's underneath the cover. If you get not enough, if you don't have enough clearance, you're going to have to increase the clearance. And increasing the clearance is pretty simple. You take the cover back off, you add extra gaskets to the standard one, or maybe even a thicker gasket, depending on the manufacturer. Briggs & Stratton uses thicker ones. They have added gaskets, but what you're effectively doing is moving this cover farther away from the gear that's on the end of that crankshaft. So you're increasing the distance between the bearing and the gear by adding gaskets. Now, if you get too much clearance, let's say you're looking at 20 thousandths clearance, that could cause knocking sounds as the crankshaft is kind of banging up and down, up and down, up and down. So what you're going to have to do in that case is you're going to take the cover off and you're going to slip a shim on the end of the crank. It's going to sit down on the gear down here. Then you're going to put the cover on. You're going to check your clearance again. Sometimes we'll put shims on it, and then we said, wow, now it's a little too tight. So now we have a shim, and then we still have to add gaskets to get within the spec. It's pretty important that you get that spec right. Leads me to my next question. Crankshaft end play may be increased with A, a thicker side cover gasket, B, a thinner side cover gasket, C, machining of the main bearing bore surface, or D, the addition of metal shims on the flywheel end of the crankshaft. So now basically we have the whole all the internal parts of the engine all reassembled. Now we have to install the cylinder head. Check the service manual to see where the different length bolts go. Sometimes cylinder bolts are different lengths. In this picture over here, you see that this bolt, and this bolt are the long bolts. The rest of them are the shorter bolts. Check the new head gasket and see if it is exactly the same as the old one. Look up the torque specs and the tightening sequence. In this particular picture, we can see this is a tightening sequence. This one's going to be 1, this one's going to be 2, 3, 4, 5, 6, 7, 8. And it's the order that you're going to torque these things. Start all bolts by hand to prevent damaging the threads. Tighten the head bolts using a torque sequence. Don't tighten all the bolts to the final torque spec. For instance, if your torque spec is 150 inch-pounds, do the first tightening at 50 inch-pounds. So you're going to go around here at 50 inch-pounds. Then you're going to increase it to 100 inch-pounds, do it again, and then 150 inch-pounds for the final torque spec. And this will stop the head from warping while you're tightening it down. If you were just to do this at 150, you're putting a lot of torque in one spot. And then you come over here and you do 150, and it tends to warp the heads more. So we got to kind of work up to that final torque. When installing an overhead valve head, we're still going to torque it down the same way as the other one, but you're going to insert each push rod down at a hole into the cylinder. And there's a hole right down in here. And here's the push rod. You're going to put that in place. Install each rocker arm. Right here's your rocker arms. Making sure that one end connects to the push rod. The other end is in over top of the valve stem over here. Install, but do not tighten the rocker arm nuts, and follow the specifications for adjusting the valve clearance right here. So we got to set that clearance right. Now the valve clearance is a whole nother lesson. We'll cover that some other day. So now final assembly and startup. Got the engine all together, got your carburetor on, you put your flywheel and starter shroud and all that stuff. And once it's all been assembled, you need to do a couple of little adjustments and checks. Check the governor control for any binding. We learned that in the fuel control side, carburetor side. Make sure that there's no binding in the governor linkages. Set the carburetor adjustment screws to factory specs. Add oil and fuel and start the engine up. Allow it to idle for a few minutes. Check for any oil leaks. Make any final carburetor adjustments such as mixture and idle speeds, which most carburetors today don't have mixtures adjustment screws, but they do have idle speed. Some manufacturers require the cylinder head to be retorqued after the engine has been run a while. Some don't. Some engines may smoke for a while after rebuild due to the rings seating. So that's not uncommon for it to smoke a little bit while the engine is breaking itself in, basically, is what we say. The rings in there have to wear down the small irregularities inside the cylinder walls. Engine may need a break-in period of up to 10 hours before engine oil consumption drops off. So you want to tell your customer not to use the engine under extreme loads for this period and to check the oil often, because most people just take a brand new engine and just go run it. That's really not good for it. Some caution tips. Many gasket kits include gaskets for different engine models. So always save old gaskets for comparisons. You might get a kit that covers 10 different engines. So you're going to have a whole bunch of gaskets in there that doesn't go to your engine. Choose the correct gasket for the job you're doing. Some gaskets may be labeled this side up or front. If so, follow the directions on the gasket. There is no universal marking system for piston and rod orientation. So always check the service manual when you're assembling those two parts together. After measuring the ring end gaps, make sure you do not mix up the rings. Return each ring to its package. Be careful not to install a piston ring upside down or in the wrong ring groove. 4-stroke and 2-stroke rings are designed with different pressures. A 4-stroke ring has the same outward pressure around the complete ring. 2-stroke rings are designed with lower pressures at the ring ends. Do not mix up the rings for these types. So, in other words, you can't be using a 4-stroke ring in a 2-stroke or a 2-stroke in a 4-stroke. The backside seating surface of an insert bearing should not be oiled or greased. So we really haven't talked about insert bearings, but we did a bunch of lessons ago. But most of the small engines don't use these types of bearings. Motorcycles, ATVs often do. So if you oil the backside of the bearing, then when you would install the connecting rod cap to the rod, it'll probably be locked up. So you only oil, lubricate the side that touches the crankshaft, not the side that touches the connecting rod. If the piston stops moving while you're installing it, stop pushing on it. Push the piston back up and out of the cylinder and try it again. Never force the piston down. Watch the position of the connecting rod in relationship to the crankshaft as the rod and piston enters the cylinder. Be careful that the rod does not contact the crankshaft and damage either part. So in other words, when you're pushing, when you're putting the piston into there, inside the cylinder, you just have to be careful where that connecting rod is. You don't want to be bashing that thing up against the cylinder walls and stuff, or have the bolts come down and ding up the journal on the crankshaft. Connecting rod torque specs are usually given in inch pounds. Don't confuse this with foot pounds. Excessive torque will ruin the rod. So you got to make sure that if your specs are in inch pounds, your torque wrench is in inch pounds. Don't confuse the two. An incorrectly installed dipper can prevent proper lubrication. On some engines, it can also hit other parts. Always count the number of needle bearings installed on the crankshaft journal, especially we're talking about 2 strokes here, and compare it to the new numbers specified in the service manual. Too many bearings will not allow assembly, and too few will result in engine failure. If the crankshaft and camshaft are not timed with each other, the valves will not open and close at the correct time. This will likely result in an engine that will not run or one that runs poorly. Especially you get it the wrong way. Maybe one tooth, it might run, but you won't have any power. It might be even hard to start. Make sure those marks are lined up. Crankshaft should turn smoothly by hand. If it doesn't rotate smoothly or it is difficult to turn, locate the problem. There's a problem, you got to fix it. Tighten the cylinder head bolts in steps, not all at once. If you don't, you can cause cylinder head warpage, which results in lots of blown head gaskets. As soon as the cylinder head is installed, gap and install the new spark plug in the spark plug hole to prevent dirt or other objects from entering the cylinder. You want to close that spark plug hole off. Now, service tips. Rod cap loosening is a common cause of engine failure. New rod cap fasteners and lock plates should be used when possible. So it's not recommended to reuse old connecting rod bolts. You should always install new ones. Sometimes a tightening sequence cannot be found for a cylinder head. So a general procedure, general rule of thumb is to follow is to tighten from the center outward, going into a circular direction, kind of like working in a circle. So opposites. So I'll take my pointer here. If you're torquing down here, the next one would be over here somewhere. And the next one could be over here somewhere. Next one could be over here somewhere. Grinding valve seats, faces, or stems changes the valve clearance. We really haven't discussed this at all in our lessons, but anytime you grind valve seats, faces, or valve stems, you change the valve clearance, and you're going to have to readjust it. Clearance must always be checked and adjusted when an engine is assembled. After final assembly, the engine should be painted factory original color and new decals installed. Kind of gives it a professional look. Engines used for rotary mowers usually use the cutting blade for cutting grass and added flywheel weight. So these engines must be mounted on the lawnmower and have the blade properly mounted before they can be started. So most people don't realize that a rotary push mower, that blade is part of the flywheel. It's just an extension of the flywheel. And they may not run if that blade is not installed there. Drain and refill the crankcase oil after 1 hour engine operation to remove any foreign material left in the engine during the assembly. So, and that, guys, is all we have. And that finishes up engine reassembly. So in the future, we'll start working on actually demonstrating how to do these. I'll show you how to install pistons. I'll show you how to install crankshafts, camshafts, how to torque things down, how to check ring end gaps and stuff like that. Thanks for listening to me today, and I'll see you on another day.